some interesting situations, stuff that you can kind of relate to pretty easily, I'm sure. Let's say this is a river, and here are the two banks, and the river is flowing this way, and there's water is flowing at, say, 3 meters per second. So there's a current, and the river flows this way. And you got your little boat, and your boat, I'm going to just park it over here. When there's no current or anything like that, your boat is able to go at, say, 8 meters per second. That's your top speed. Okay? So now, if you were going down this way, and you were going at your full speed, so you'd have the 3 meters per second plus your 8 meters per second, and you'd end up going at 11 meters per second. That's kind of easy to see. Same thing like we did with relative velocities earlier on in the course. If you were going upstream, and that was your boat, and so you'd be going up at 8 meters per second, but this thing would be pushing you back at 3 meters per second, so your final velocity, or your basically resultant velocity, would be 5 meters per second. So we just 8 minus 3, or 8 plus 3 in here. And it's kind of simple to see what would be going on there. Now let's take this a little step further and say, oh, see the same bank, and the water is still flowing here at 3 meters per second. And I'll make that a little bit smaller. So 3 meters per second, 3 meters per second. And so it's flowing this way, and you want to take your boat directly across. Well, you kind of know that your boat's not just going to go straight across. It's kind of going to go kind of like this as the water keeps pushing you down. And so you could easily depict this as vectors. You got your 8 meters per second and your 3 meters per second, and that gives you a picture of what direction your boat is actually going to take, because you're going 8 meters per second in this, and then you get the same time you meant 3 meters per second this way. So that's where your final velocity would be pointing. You'd be pointing in that direction, and you would have a value which could easily be calculated using the Pythagorean. 8 squared plus 3 squared, what's that, 64 plus 9, the square root of 71, which would be 8 point something. And so that would be the square root of 71, I'll just write it as that, would be your velocity going in that direction. And so let's say if this was just like our previous thing with the northeast, southwest, this was north and east and west, and I'm sorry, south and west. That was silly. And if I wanted to tell them, hey, what direction am I really heading? Well, here's east, and so this is the angle that I'd be interested in. I'm kind of going this way, right? And so what angle is this, so that, I know where I'm going to finally end up when I get to the other side. And so that could be easily figured out again using trig. And so I hope you see that you have a 3 and an 8, and that's the angle you're looking for. So it'd be the tangent inverse of 3 over 8. And then that would give you this angle. And so when you were to depict what is this angle going to be, you would say, and again, I don't know what 3 over 8 is going to end up being. This is going to be an acute angle of some sort. But you would say that that would be the angle, and I hope you would write that as south of east. So whatever angle you get over here, we're using this tangent 3 over that would be your angle south of east. And 71, square root of 71 would be your velocity. So you'd actually be writing that's the square root of 71, whatever that number might be, at an angle of tangent inverse of 3 over 8, whatever that would end up being. You can plug these in your calculator, and then finally you'd put in south of east. Okay, sometimes they may not write the F and just put an SO, south of east, but that's how you would write where you're going to finally end up pointing and what your final resultant velocity is going to be. Okay, just don't have a calculator right in front of me, so don't know what these numbers are, but I know you guys can easily plug them in and figure it out. All right, bye for now.